All right, cool. So what we're going to talk about today, we'll talk about MCP a little bit. We'll talk about that in terms of APIs. I'm going to talk specifically about some of the security challenges and the security challenges we face with MCP. And then we're going to look at a way to solve some of those security challenges using a product from FINOS called Calm Architecture as Code. So we're going to do a demo. That's where everything will probably go wrong, and I'll have to maybe get Matt to just come up and hold this so I can type at the same time, which would be funny. And then we're going to have Matt come and talk about what controls are, which is a part of the FINOS Calm Architecture as Controls framework. So who am I? My name's James or Jim Gough, distinguished engineer at Morgan Stanley, working mostly on APIs and our API program. I'm also a Java champion, so I've been involved in open source for a fair amount of time. And I've written 2 books, one on mastering API architecture and another on optimizing cloud-native Java. They couldn't be more different, but that sort of shows the type of things that I work on. And more recently, I've got involved in contributing through FINOS to a project called Calm. That's been really nice because in the past, I've worked a lot on open source things and books, and you kind of end up working late in the evenings and early in the mornings to get those types of things finished. So it's really nice to be able to bring both things that I do together. We're a really heavy user of Calm within my team. I'll talk a little bit about how we've used it as part of this presentation as well. Okay, so let's kick off with talking about MCP. We've only got 30 minutes. I could probably talk about this for a few hours, so I'm just going to try and give you a little primer so you can understand why we're using architecture as code for this problem. So MCP stands for the Model Context Protocol. I'm imagining that everybody has come across this. I think I've said I used to say API all the time, and I think I've said MCP more than API in the last 2 weeks, so acronyms everywhere. It's a protocol that connects agents and LLMs to external systems. So I kind of view it as a facade or a wrapper that really enables us to wrap typed capabilities in a well-known structure. Now, I'm going to propose that for the rest of this talk, when I talk about MCP, I'm going to be referring to it connecting to APIs. That's because that's what I predominantly do in my world. It doesn't mean that's the only thing it can do, but that's just how I'm thinking of it from a security perspective. It uses JSON schema, so there's contracts in here. It's bidirectional over an RPC connection. So if you're used to REST APIs and Open API specifications, it's not really that. And that was the first mistake I made when I started thinking about MCP. Think about an RPC connection that you might have had many years ago, and now it's come back again in a different form to fuel AI. That's pretty much what's going on. So think of it as a decorator and think about it being part of your existing API security stack. So what is it at the core? There are 3 things that we're going to look at. We're actually going to have a demonstration of tools today. Tools are structured operations, and they enable a specific task to be performed. When I say it's structured, we'll see a little bit about how that works and how the LLM interacts with it. Basically, this has got some descriptions in there that allow for tool selection, deciding what you're going to execute at runtime. So we'll hopefully see that working if my demo works. The other thing that you can use here is things called prompts. And what prompts enable you to do is have reusable, almost patterns of interaction. So if you've got common things that you're going to be doing over and over again, or you want to really try and trap or guide the behavior, this is one of the things that you can use inside your tool set. What I would say is that these 2 things, the more that you can narrow down what optionality you have, the better the results that you're going to get overall. So these 2 things play together quite nicely. If you've only got 1 or 2 tools like me, the problem is really easy. If you've got loads, the complexity ramps up very fast. So there's a lot of stuff that I'm going to talk about where I'm going to go, MCP is really simple. It's a very simple protocol, but its usage is horrendously complex as you start to scale this thing. So just bear that in mind. Please don't go back to your organization. Jim said, everything's really easy, so that's fine. And then you've got your resources, which are documents, data, any events that you want to share as part of it. So if you use Copilot and you have your selector window and you're saying, look at this file, that's like sharing a resource effectively with the interaction. Now, if you're familiar with API security controls, MCP controls look quite similar. They're not too different at the core. You've still got the requirement to do authentication and authorization. You've got to look at rate limits and quotas, and we're going to look at that within, or you can look at that within gateways that you may already have. Input validation. So the thing that usually catches people out here is input validation is pretty much turned on by default. So you've got to really conform with some of the specifications that you publish. And the TLS and audit logging is pretty much a standard in our industry. But do we have an industry problem with AI? This is just my little teaser slide. I'm not going to go into this much other than to say there's quite a lot of things where we look, especially with MCP as a protocol, which is almost a reinvention of certain parts of what we've already seen in industry for many, many years. I think one of my sort of examples here would be where the protocol did not use OAuth 2 to start with. Almost everywhere else in industry for APIs we're using OAuth 2. And then the OAuth 2 IDP was part of the MCP server, which doesn't really work from securing your tokens so that they're separate from the actual execution path. So if anything, we need to start learning from some of the stuff that we've seen from decades of good practice in industry. There are some new problems, that's for sure. There are also some old problems that we're resolving in different ways with different names. So that's the other thing I'll say about that. Cool, so security challenges. Let's have a look at an architecture. Hopefully, folks have come across C4 architecture for a way of conveying and communicating design. This is something that I think it was back in 2017 when I first started working on the API program at Morgan Stanley, of thinking, I need to share what I'm going to do. There was only me at this point. There was nobody else working on APIs for a big program. So I used C4 because it enabled me to document and communicate the types of things that we're working on. So in this is going to document the example that you'll see today. We're going to use Claude as the interaction point. And we're going to use that to look at our operational reports. So when I was writing this, I was doing a lot of work with some of our SRE stuff. So it just became the inspiration. It's not the most exciting demo in that respect. It's got an MCP server that I'm going to deploy on a Kubernetes cluster. That MCP server is going to have 3 different things. It's going to have list reports, read reports, and load URL. So those are the tools that exist within that MCP server. And my intention is that I'm going to use that to retrieve operational reports from an API that already exists. So trying to reuse my existing technologies. Now, when I put this slide together, I was thinking about how can I call something I don't want people to see? I'll call it the secret service. And then I realized that in the US, that has a whole different context to what I was thinking about in the UK. So the secret service is not as exciting as it might appear. It's just another API that hosts something that you should not be able to access. Now, when it comes to things like tool chaining attacks, which is a new type of threat that we see when using MCP, the idea is that you potentially chain tools together and use them in a way that they might not have been intended to be used. Now, this is quite difficult because when we start thinking about software reuse and technology, we often try and build things small and reuse them across many problems. But now, one thing that you have that's quite interesting with tools like LLMs is they can actually find things that you probably wouldn't find if you were a developer just poking around. They're able to interpret, they're able to look at what's available, potentially chain things together in unreasonable ways. Say unreasonable in the sense it's probably quite reasonable for it to try and read that service, but it's not intended behavior. So we'll actually see a demo of how that works. And we're going to use a feature inside Kubernetes called micro-segmentation to block that service from it being possible to call. So we start to build up that security story using Calm. Now, there are further vulnerabilities that are new. I don't need to think that it's just tool chaining that's the only one. What I would say is, as we talk through micro-segmentation, the majority of these specific security challenges that we see, the threat or the impact of them are lowered by using micro-segmentation. So although it's not going to be an answer to everything, and I'm not going to go through these all one by one, there is a partial mitigation that you get from using tools like Calm with micro-segmentation. So we're going to have a very quick primer on architecture as code, because for me to show you a demo, you kind of need to be able to see a little bit of understand a little bit of what I'm going to show you. So Calm stands for the Common Architecture Language Model. There's lots of jokes that go, keep calm. Like people tell me that all the time whenever I'm talking about this stuff. And carry on is usually the punchline that comes after it. Basically, it's a core model at its heart. So where the core model itself is a JSON meta schema. So if you like JSON schema, and that's the quietest I've ever heard an audience. No reaction whatsoever, JSON schema, oh God, okay. So there's a JSON meta schema that represents the core model. We'll talk about a little bit about how that works as we observe some of our patterns, but basically it sets out some constraints for us to describe architecture. those constraints are not particularly strong. So if you're sat there going, oh no, it's another schema that's going to be really complicated, it's not that bad, okay? You can make it more complicated, like within your own use cases, but that's the point. It shouldn't be at the core level. There's also a series of CLI tools, and we'll look at how those CLI tools can be used, or at least a subset of those within your projects. And then there's the ability to create patterns. Now, patterns are the real superpower of Calm. They enable me as an architect to convey architecture opinions to developers, and then enables them to essentially create from the back of the pattern how they are going to use that for their particular business problem. So this is really quite cool. So as an example, at Morgan Stanley, I have patterns for how API connectivity works, and my developers work on architectures that follow that pattern, and then I can deploy their systems across my infrastructure. So that kind of like loop around SDLC we'll come back to in a little while, but it really sort of sets us up for communicating how we want a platform to be used in that sense. Now, going back to our existing diagram, C4, we mentioned that's really great. In terminology, when it comes to Calm, each of the boxes that you see on this diagram are represented by something that we call a node. Those nodes actually have very simply a name and a description and a node type. So at its very, very core, it kind of is C4. Like there's nothing much more at this point on top of what you would see in a C4 diagram. There's more that comes into this position later, so I don't think that's all it is. There's some other things I'll show you. Relationships are all the dotted lines that you see. So we've got a couple of different types of relationships here. We've got a connects relationship. We've also got a deployed in or contains relationship, which the Kubernetes cluster is part of. In terms of what that looks like, this is the connect one. It's got a source node and a destination node. They're reusing the unique ID. So the unique ID is an important link item. You might wonder how this all kind of works with validation. How does this kind of fit together and actually be proven to work? This is where we've got some of the CLI tooling that does not just schema validation, but also validates things like, does the MCP client actually exist? Which is great for me because I type things wrong all the time. The other one is the deployed in relationship, which you can see has got, again, the unique IDs in a list of nodes. So if you understand these little pieces, you can pretty much get the idea of what the picture of Calm looks like. Now, this is where we start to add more. And this is for me where, especially when we start talking about patterns and conveying patterns, you're able to add more detail in terms of what you expect. So as an example, there are two interfaces that I'm going to show you as part of our MCP server deployment pattern, which is going to include the image interface. So the image interface is going to be specified on the pattern and say, I'm going to ask the user to provide the name of the Docker image or container image that you want to run in Kubernetes. The other side here is also give me the port. Now, if you think about it, within this example where I'm going to show you MCP server, imagine if you could provide any image, any downstream API, so it might not be operational reports anymore, and any port that you use. That then gives us a secure pattern for deploying any MCP server with one API. So that's where the power of this stuff kind of comes in and ties together. So let's have a look at a demo. Cool. I'll try put this down here. Can people still hear me with that like that? Okay, all right, cool. I shout loud enough anyway. We'll see. Yeah, there we go. That's cool. All right, roll up the sleeves. Claude. We're going to ask Claude to start looking at our operational report. So we're going to go, yo, Claude. Now, the other thing is, the more casual you are, the more information it will give you back. So it's going to give me more details than I might expect. So yo, Claude, show me my latest operational, if I can type, reports. Now, that could actually cause a problem. We'll see if it's smart enough to realize what I'm asking for. Okay, so it's actually calling. So this is calling my MCP server now, which is, it didn't do this yesterday. It got a bit annoyed with me. So it's found one report. Okay, that sounds cool. Would you like to read the content? Yes. Reduce by typing. So now I'm going to go back to the MCP server. It's going to use our read file. And it's going to have a look in here. Oh, you've got your weekly ops report here. Your uptime is good. You can tell I was definitely thinking about my own system. Oh, a few incidents occurred. No, anybody who knows me, just forget that bit. Additional volatility from month end. Yeah, that's fine with month end. Oh, and there's some additional metrics that are located at dev and prod. So you can see here now, all right, well, we've got some information back that maybe we didn't expect. Would you like me to fetch any detailed metrics for you? Oh, yes, please. Yeah, let's do the prod one. Prod, please. And it's going to go and it's going to try and access that particular. So it's using that fetch URL tool now, that very nicely flexible tool, and it comes back with the flag. This appears to be a demo flag or placeholder value. Is this what you were expecting to see? Sometimes it looks like you're running a security demo again. But you see that this is now, imagine I'm a developer, I've deployed this on my own, done everything right, or at least I thought I had, and I've missed something off, I missed a configuration, now we're in trouble. So that's the deployment that's not sort of configured using Calm. How do we now take Calm and a pattern to solve that? You get to look at some JSON schema. Oh, there is some excitement for JSON schema. We'll minimize the amount of JSON schema that you need to look at. So you can see here I've got this pattern. It's an MCP architecture pattern as stated at the top here. You can see that we've got our MCP client, that's Claude. There's nothing too much interesting there. Let's go down and look at the MCP server, mostly because this is where the interface is present. So here we've got the container image interface. Now you'll see here that I'm actually pointing that down to a definition. Now that's great because that means that I can define something that's used over and over in the architecture, and all that says is you need to provide the image name. There's nothing else in there. And what I'm doing is I'm giving it a unique ID as part of this as well, so that I can reference it. So it's always going to be consistent within the architecture, which means I can weave things together, and the developer has a bit of flexibility to provide that. There's also then the port interface as well. So if I was a developer using this now, I would use Calm, and I would generate from the pattern an architecture. So I'm going to hit enter. It's going to generate me an architecture. Off the back of that, it will create somewhere over here architecture.json, and you can see here now that it fills this out. Oops, sorry. And here it's got some of the placeholder values. So it's saying you need to put your image name in here. You need to put your port in here as well. Now, when you use a tool called Calm Validate, it will point out that you've still got placeholders in your architecture. Now, I think I've held you on to the excitement of looking at JSON schema. What if you don't want to look at JSON schema? Well, there are a couple of options that you've got. The first is a product that we're working on in open source now, which is called Calm Hub. So Calm Hub is a repository of architectures, patterns. You can put ADRs in there as well. You can define standards that you use within your organization. But this starts to really bring to life the actual architecture itself. Now, our goal with this is not just to be able to visualize, but actually connect things together. So if in your architecture you have an ADR that's from somewhere else, you'd be able to click on the reports MCP server, and you definitely won't be able to see that text on the right. Apologies, I can't make it bigger. That's a feature request that's gone in just as we're talking here. So that side gives you more info. Now, eventually you want to be able to navigate between the two things, getting attacked from all angles. The other thing that you'll see here is the reports API down at this side. It actually introduces, sorry, not the reports API, the secret API down here introduces some controls. Now, what I'm saying here is I'm specifying this has got to be micro-segmented. So it says lock down an individual pod workload. So as part of my deployment, I can interpret the controls and make sure that my architecture is deployed in the right way. So interfaces bring in optionality from the user. You actually, within the reports MCP server here, it's saying JP Gough MCP server. That's just what I have running locally here. And it gives you that sort of ability to do this. Now, let's go back to our IDE because drawing diagrams and doing architecture, it's all good so far, but maybe we're not quite sold. So the next thing that you could do, and I'm just going to try and make this a little bit bigger here, is there's another tool called Calm Template. Now, what Calm Template enables you to do is provide something called a bundle. And in the IDE on the left here, just hidden to the side, I've got a Kubernetes deployment bundle that knows about the pattern. So what that means is I could take the bundle, feed it the architecture, and it's going to generate me something, and I'm going to say something because that could legitimately be almost anything, that's going to enable me to do something with Calm as an architecture file. So examples that we've got being able to create documentation, so being able to create websites off the back of your architecture, also being able to fill out Kubernetes manifests and resources. That's what we're going to do to secure our cluster. You could also do a two-step approach where you actually generate your Terraform to provision your cluster and then Kubernetes to be able to then configure the cluster as well. So this means that I have a mechanism to take what is in this architecture and push it into production with the right controls in place. So that's where the two things start to tie together. If we had a look at the details API, If you're familiar with handlebars as a templatizing technology, it effectively has tell me what the report's API image is going to be, tell me what the port is going to be, and that's how it kind of ties the two things together. So if we run calm template now, it's going to generate me down in this infrastructure folder because that's where I specified the output. We'll just look at one of them. It's now got inside here the details JVM. So Quarkus applications all up and running, all ready to run. So that's cool. So the next step we're going to do is actually run kubectl apply -k. So we're using customize here if you've not come across it. And what you'll see is nothing has changed because that was all what I just demoed you. But the key thing is it's now added a network policy. You typically don't want developers fiddling around with network policies. You want those to be automatically wrapped into a particular mechanism of how you deploy. Now, in this case, I've just made that not be connectable. In the way that I do this within my day job is we actually wire things together so that only slices of the application architecture can connect together. Now, if we go back to Claude and say, please try read the URL again, it's expected to hang, by the way. So I was building up some drama. So it's going to hang because what happens with microsegmentation in Kubernetes, it doesn't return a response immediately. It kind of tars up the request. So this is just going to spin around until it eventually times out now. So what we've done is there's been no change in what the user would have to supply, what you'd have to build, but we've now got segmentation and security that's present across our architecture. Cool. So what I'm going to do now is I'm going to hand over to Matt to talk to you a little bit more about how controls fit in with the rest of Calm. Sorry.
Thanks, Jim. So I'm Matthew Bain. I'm also a distinguished engineer at Morgan Stanley and one of the creators of Calm and lead maintainers. And so, yeah, Jim's already been through what it is that Calm gives us as a language to be able to model architectures. Normally with architecture tools, things like C4, Structurizer, they tend to be more about diagrams, about talking about architecture, and they're really valuable for that. But one of the things that we've been trying to do with Calm is to be able to capture those non-functional aspects, those non-functional requirements, so that we can reason more and actually get closer to the security teams, the policy teams, to be able to actually integrate that into the developer workflow. And so really the things we're talking about are the illities. If you're an architect or work with architects, you'll hear about the illities, things like observability, maintainability, reliability. Those are the things that we want to be able to capture with controls. So, we've got a few of the non-functional domains here, such as the security domain, observability, performance. Sorry, you're not able to hear me. What we can do with these, so control is very lightweight. It is effective. That no better?
It's not. No, it's on. You just need to go.
So that better? Excellent. So the control itself, a control is effectively a JSON schema. So it gives you the ability to define what it is that you need to capture for any given control. And you can apply standards. So a standard is a way for you to, within your organization, provide additional properties that you want to be able to capture. So this might be across your organization, or it might be across the particular domain that you're interested in. So this is an example of a control here, and we've effectively just taken the NIST document standard, and we've captured the document number, the title, and the status. So not particularly exciting in this case, but it allows us to actually take these well-known public standards and map them into our actual architecture so that developers know about them at the time that they're developing the application. And so the control is made up of these two things: a control requirement, that's the schema that we were talking about, so the definition of what it is you want to be able to capture. You're in complete control of that as an architect about what it is that you want to be able to capture, and you can make that more or less something that you could enforce with the system. So actually turn a control gate around it. And then you've got the control configuration. And a control configuration can be mapped inline in your architecture. So this is the how am I going to do this? Or that in itself can be an external separate JSON document that you want to be able to share. Because it may well be that you've got control teams, the security teams, the audit teams, who actually want to give you one or more ways that you can comply with a given control requirement, so you can just reuse those and point to them. The Calm Hub that Jim was showing earlier, you'll be able to publish the controls along with your other artifacts into Calm Hub for sharing so that they can be referenced and reused. And as you saw, microsegmentation, what you saw there was an example of taking a very specific, very enforceable control and applying that into the Kubernetes cluster that Jim was showing off in the demo. So what's the potential workflow? You saw the C4 design and review, and this is very much the way that we would have worked historically. We'd produce the design in C4, we'd use it to communicate, and we'd kind of finish there. But now we can actually create the pattern, so we can create that reusable pattern. Jim talks about the API platform. Within the API platform, there's over 100 APIs within Morgan Stanley that are deployed, but we've only got 3 patterns in terms of how you actually connect back from the internet into the secure network. And that's really powerful because that means there's only 3 ways, but we can reuse that time and time and time again. And that's why we do talk about patterns being the superpower of Calm. You then publish that out to Calm Hub so that the artifact can be shared, can be controlled, and can be reused. You generate your architecture, as you saw, and then you validate that and store it back into Calm Hub so that you can version control it. And certainly one of the things that we're looking to do as we evolve Calm is to then be able to use that as a control gate. So think about being able to actually have your pull request or your change, the point at which you're going to deploy, be able to actually check back to your architecture and make sure, is the thing that you're trying to check into source control or the thing that you're trying to deploy into production, does it actually match the intended architecture? And so we take architecture off the whiteboard and make it something actually measurable and controllable. And then finally, you can take those artifacts that have been generated, and again, as you saw through the demo, actually be able to generate infrastructure as code and be able to generate documentation. We've also got a really powerful way of being able to turn the architecture documentation into a knowledge base. Again, this thing that you can put in the hands of your developer with a Copilot chat mode so that your developers can actually ask questions of the architecture. And we found that really powerful because there's never enough architects within an organization to be able to sit down and speak with your developers at the point at which they've got a question. This structured model means that in conjunction with an LLM, it becomes that expert enterprise architect that can be there with each of your developers to ask questions of whenever they need it. And that's it. So just to queue up, there are a few other talks today and tomorrow that are going to involve Calm. So there's one at 4:20 with Paul Merison from Tetrate, and there's going to be quite an exciting unveiling there of a new contribution to the Calm project. At 5 o'clock, I will be speaking with Eddie Knight from Sonatype about Secure by Design, and we'll talk some more about patterns and controls. And then tomorrow, there's a Birds of a Feather session with Carl Moll over by the door and Paul Merison as well. And I'm sure a few of us from Calm will be around too. So with that, if you've got any questions for Jim or I, otherwise, you're welcome to move on to your next session. Thank you very much.